talk about inverse trig functions. So first we need to define a few things. Whenever you see the cosine inverse, this -1 means inverse. Now, there's a slight problem with that. For example, usually when you saw a power or a number in that location, it was a power. If this number is not -1, then yes, it's a power. That is, this means cosine x to the third power. You have cosine with a 2 up there. This does mean cosine x all squared. When this number is -1, this is not cosine x to the -1, it is not that, which is 1 over cosine x, which happens to be secant x. -1 power means reciprocal. That is not the power. It means inverse. Okay, having stated that, let's give the definition of what I have on the board on the top. This means that cosine of y is equal to x, and this is very important, and x is between 0 and 180 degrees. When you have sine inverse of x equals y, this means that, basically interchange these. This means that the sine of y is equal to x, and x is in between -90 and +90. You can actually equal their endpoints. X can equal -90 and x can equal +90. Okay, the last one is the tan inverse of x equals y. What does that mean? This means that the tangent of y equals x, and x is in between somewhere. X is in between -90 or negative pi over 2 up to positive pi over 2. Okay, these are definitions. You cannot do any trig inverse problems without knowing this definition. So, the first set of problems is to find the exact value of the following. Find the exact value of the following. What is sine inverse of a half? Well, personally, I would call it something. I would call it x. So, this here means the sine of x is equal to a half, and x must be between -90 and +90 degrees. Well, so let's draw something. Now, so you're somewhere between -90 and 90. That is x is either in quadrant 4 or it's in quadrant 1. Since the sine of x is a positive answer, that means we are in quadrant 1. Because sine is positive in 1 and negative in 4. So we're in quadrant 1. Here's angle x. And the sine. Opposite over hypotenuse. 1 over 2. Now you should recognize this triangle. If this is square root of 3. This angle is 30 degrees. So we're done. X is equal to 30 degrees, and it is in between -90 and 90. So let's try another one. I'm going to keep erasing the work That way I have the formulas in front of me. And so do you. If you are asked to find the cosine inverse of the square root of 3 over 2, but negative. Okay, find out what that is. Well, I would call it something. I'd call it x. Well, this here means the cosine of x is negative square root of 3 over 2, and x is in the cosine. You're between 0 and 180. That is, x is in quadrant 1 or 2. After all, that is between 0 and 180. If you prefer, you can write that. X is in between 0 and 180. But that means quadrant 1 and 2. Of those two quadrants, cosine is negative in quadrant 2. Cosine is also negative in quadrant 3. The cosine inverse is not defined in quadrant 3. Okay, so I have a cosine. So let me do it here. Adjacent over hypotenuse. Adjacent is negative the square root of 3, and hypotenuse is 2, and Pythagoras would remind us that's 1. Question is, what is this angle? Okay, what is that angle? That's angle x. Well, if we knew the reference angle would be okay. This reference angle is 30 degrees. So x must be 150. X is going to be 180 minus the reference angle, or 150. Why is that the case? Let me draw a bigger picture and we'll look at it more carefully. We know the reference angle is 30. Well, how can I get to here in a way where I can know how big that angle is? Well, you can mess up. You can go further than you meant to. You can go 180. Why 180? Because I know where 180 is. And then I can come back exactly 30. Because I know this is 30. And 180 minus 30 is 150. So that's the answer. X is equal to 150 degrees. Or you can write it in radians. Okay, let's try another one. Each trig function is defined in two quadrants. One of those quadrants will be positive, and the other quadrant will be negative. For example, if you were asked to find the tangent inverse of square root of 3. Let's make a negative square root of 3. Well, let's call it something. Let's call it x. Well, this means that the tangent of x is negative the square root of 3. And x is in between negative 90 degrees and positive 90 degrees. That's what that means. So this here is quadrant 1 and quadrant 4. Negative 90 to 0 is quadrant 4, and 0 to 90 is quadrant 1. Since it's negative, we're in quadrant 4. All trig functions contain or allow quadrant 1. Everything is positive in quadrant number 1. If you want negative, you're in that other quadrant, quadrant number 4. Okay, and remember that negative square root of 3 is the same as negative square root of 3 over 1. Opposite over adjacent. Now, it might be that they're adjacent. The denominator is a negative 1. We don't know yet. One of these two will be negative. Square root is 3 over 1. And since this is going down, yeah, the square root of 3 was a negative. And since this is going to the right, it's positive. The question is, is in this direction, how big is that angle? Well, again, you should recognize this as this is 60, opposite square root of 3 is 60, and opposite 1 is 30, right angle. So, it's a 30, 60, 90 triangle. This here is negative 60. X is negative 60. I agree that it's also 300, that angle. But I'm not going to say 300 because 300 is not in between negative 90 and 90. 300 is not in between there. You have to give the answer the way they want it. And how they want it is defined above in the definitions. The answer has to be between negative 90 and 90. If they ask you for the sine inverse of square root of 2 over 2, well, first thing you should realize is that they simplified square root of 2 over 2. It's really 1 over square root of 2. Why do I want that? Well, you'll see in a moment. So call this x. So then we know the sine of x is 1 over square root of 2, and that x is in between negative 90 and positive 90 degrees. Now, the reason we wanted to write square root of 2 over 2 as 1 over square root of 2, okay, so since sine of x is positive, we're in quadrant 1. So quadrant 1. Now, if I would say the opposite is square root of 2 and the hypotenuse is 2, because I'm using square root of 2 over 2, I don't recognize those as numbers that correspond to one of those special triangles which I remembered. It does not. But square root of 2 over 2 is 1 over square root of 2. That is the opposite. Sine is opposite over hypotenuse. The opposite is 1, and the hypotenuse is square root of 2. And you say, oh, I recognize this triangle. Whether you write down the square root of 3 or not, you should recognize this angle as 30 degrees. That x is 30 degrees, and this is a valid answer because it's in between negative 90 and 90. And here the answer, x is 30 degrees. So sometimes you have to change the way they write. They write square root of 2 over 2, and you think 1 over square root of 2. For example, if you were asked for the tan inverse of negative square root of 3 over 3, tan inverse of that, well, you need to start reviewing that square root of 3 over 3 is 1 over square root of 3. Hint, the square root of any number divided by that number is 1 over the square root of that number. And to prove this, this certainly equals itself times 1. And this is how I choose to write my 1. Now, square root of n times square root of n is n, divided by n square root of n. Well, n over n is 1. So I do get 1 over square root of n. That is, the square root of 7 over 7 is 1 over the square root of 7. The square root of any number divided by that number is 1 over the square root of that number. You insert the number. If it's 11, fine. It's 1 over square root of 11. Learn that, otherwise you're not going to be able to do the problem in front of us, nor would you have been able to do the last problem. So we have this. Well, call it x. So now we know that the tangent of x is negative 1 over square root of 3. And for tangent, x is in between negative 90 degrees and positive 90 degrees. So Since it's negative, now negative 90 to positive 90 is quadrant 1 and 4. Tangent is positive in quadrant 1. So our angle is in quadrant 4. And we want to know what this angle is. Well, we know the opposite is 1, and the adjacent square root is 3. And it turns out the opposite is a negative 1. For example, though trig inverse doesn't allow it, if we were in quadrant number 2, it wouldn't be negative 1 over the square root of 3, because this is going up. That would have been the positive. And since the square root of 3 is going to the left, it would have been the negative. You never have these problems with sines and cosines, because the denominator is always the hypotenuse, which is always positive. Okay, so now we should recognize this as a 1, 2, square root of 3. Opposite 1 is 30 degrees. So our x is negative 30 degrees, because we're going backwards. And we like that answer because it's between negative 30 degrees is in between negative 90 and positive 90. Okay, so x is negative 30 degrees. So let's try this one. Now sometimes you can't get an answer. And I guess that's the big hint. We're not going to be able to get an answer in this problem. Example, I asked you for the cosine inverse of 5. Well, call it x. So that means the cosine of x equals 5. And x is in between 0 and 180. X is in between 0 degrees and 180 degrees. But if you consider the cosine graph for a moment, the highest it goes is 1 and the lowest it goes is negative 1. Negative 1. It's never 5. This has no solution. This has no solution. Okay, it's never 5. Cosine of no x is 5. Okay, I mean, if this mark is a half, the cosine is sometimes a half. For example, the cosine is a half for that x value and for that x value. But it's never 5. And 5's up here, and I don't hit the graph. Cosine of no x is 5. So sometimes you don't get an answer. Okay, let's move on to a different type of problems involving trigonometric inverse functions. Now, first I want to point out that what this equals, let's call it y, doesn't matter. This equals an angle. The cosine of the angle equals x. That is, this means the cosine of the angle equals x. That is, theta is an angle. But this is theta. This is an angle. Sine inverse of x is equal to an angle. Because this here means the sine of that, and you only take sine of angles, sine of angle equal x. Same with tangent. The trig inverse of something is an angle. Trig inverse of x, or cosine inverse of x is an angle. Tangent inverse of x is an angle. And you have to understand that. It's an angle. And the angle has to lie in the correct area. How about we consider this problem here? Think about it nicely, nice and slowly. Pretty straightforward. What is the sine of the sine inverse of a half? Now, what's in the brackets is an angle. It's an angle. And we want the sine of that angle. We want the sine of that angle. Well, let's look at the angle more carefully. We're calling it theta. This statement right here says the sine of theta is equal to a half. Okay? But that's what we want. We want the sine of theta. Oh, it's a half. Done. Kaput. Finished. If you were asked to find the cosine inverse of 2/3. Well, what's in here is an angle. Call it theta. We want the cosine of theta. Okay, so we'll do that in a moment, but let's see what's in here. We know that the cosine inverse of 2/3, we're calling it theta. Because cosine inverses of a number is equal to an angle. But this statement right here says the cosine of theta is 2/3. And that's what we want. We want the cosine of this. So this is theta. The cosine of theta is 2/3. If you have the tangent of the tan inverse of 17, well, we call this theta because tan inverses equal an angle. So what's in there means the tangent of theta is 17. But that's what we want. We want the tangent of theta is 17. Okay. Now let's look at one more. Suppose you had the cosine inverse of 32. Well, cosine inverses are an angle. So we want the cosine of that angle. But we're calling the cosine inverse of 32 theta. That means the cosine of theta is equal to 32. So you might want to say, oh, the answer is 32. Cosine of no angle can ever equal 32. That is, what's in here makes no sense. Cosine inverse, you cannot take the cosine inverse of a number other than numbers between -1 and 1. So this answer does not exist. That is, there is no answer. It's not 32. This is gibberish. Cosine inverse of 32 is gibberish. So sometimes you don't get an answer. But now if you remember tan graphs, they go up to positive infinity and negative infinity. That is why you can take the tan inverse of 17. So other than the times when there are no answers, you can kind of read off the answer. Excuse me a moment. Okay. For example, if you're given the sine inverse of negative a quarter, but the answer is just negative a quarter. Okay, so let's write it so one can read it. Negative a quarter, the answer is negative a quarter. Okay, you can kind of just read it off. That's the answer, negative a quarter. So that's if you have sine and sine inverse, or cosine and cosine inverse. What if it's not that? And here's where it becomes a little bit harder. What if you have to find out the cosine of the sine inverse of 3/5? Okay, so what's in here is an angle. And we know something about the angle. We know that the sine of the angle from negative 90 to 0, that's quadrant 4. Negative 90 to 0. And then from 0 to 90, 0 to 90 degrees, this is quadrant 1. Okay, so since the sine is positive, we're in quadrant 1. So we draw our picture in quadrant 1. We know the sine of theta is 3 over 5. If you're positive and you're trig inverse, you're always in quadrant 1. If the sine of the angle is positive, you're always, and it's a trig inverse, you're in quadrant 1. Okay, so I draw my picture in quadrant 1. So opposite over hypotenuse. Now, you should and this is angle theta. And you should recognize that 4. 3, 4, 5, right triangle. If you don't, call it x. 3 squared, call this x. 3 squared plus x squared is 5 squared. 9 plus x squared is 25. 9 plus x squared is 25. 9 to x squared must be 16. 9 plus 16 is 25. So x squared is 16, which means x is plus or minus 4. It's plus 4 because we're going to the right. Now I really want to find the cosine of this, which I'm calling theta. I can read it off. The cosine of theta. I have the triangle where the angle is theta. The cosine is adjacent over hypotenuse. It's 4 over 5. And that's your answer. This equals 4/5. 4 over 5. You have to draw the triangle. We were asked to find the sine, not the sine inverse. We were asked to find the sine of the cosine inverse of 2 over 7. Now this makes sense because that's between negative 1 and 1. Well, this is equal to an angle. And basically, we want the sine of that angle. We want the sine of theta. But we know stuff about theta. We know that the cosine inverse of 2 over 7 is theta. That is, we know that the cosine of theta is 2 over 7, and that theta is in between 0 degrees and 180 degrees. And since the cosine of theta is a positive answer, we're in quadrant 1. Adjacent over hypotenuse. Now we want the sine, and here's theta. We want the sine of theta. That is, we want the opposite over hypotenuse. Well, we don't have the opposite. We have to figure out what it is. Let's call it y. 2 squared plus y squared is 7 squared. 4 plus some unknown number. That's the unknown number. It's 49. 7 squared is 49. 4 plus what equals 49? 45. 4 plus what gives you 49? That is what goes here. Well, 4 plus 5 gives you 9, and there's an understood 0 here. 0 plus 4 gives you 4. 45. Y squared must be 45. So in turn, y must be plus or minus the square root of 45. And since our y is going up, it's plus square root of 45. So now we know y. It's the square root 45. In particular, we know the opposite. Opposite of theta is square root of 45. Okay? So the sine of theta is opposite over hypotenuse, which is 7. Problem's done. Okay, these problems generate a triangle, and you have to negative 2/3. Sine inverse of a number, that's an angle. You need to be able to say that. Sine inverse of a number is an angle, so I called it an angle. That is, we want to find the tangent of that angle. Oh my, how do we do that? Well, we know something about the angle. We know that to switch those two. We know the sine of the angle is negative 2/3. And the angle is in between negative 90 and positive 90. Since the sine of the angle is negative, it's not in quadrant 1. It must be in that other quadrant, quadrant 4. Sine inverse is defined in quadrant 4 and 1. Okay, sine. Here's theta, sine. Opposite over hypotenuse. Now, since we want the tangent, we want the opposite over adjacent. Oops, we don't have the adjacent. Let's call it x. So we know that x squared plus negative 2 squared is equal to 3 squared. Negative 2 squared is 4. 3 squared is 9. What plus 4 equals 9? 5. 5 plus 4 is 9. So x squared is 5. And then x is plus or minus the square root of 5. And since x is to the right, we'll just keep the positive root. So now we know x is square root of 5. Tangent of theta is opposite over adjacent. Negative 2 over the square root of 5. Multiply top and bottom by square root of 5, because when you multiply those two bottoms, you don't have a square root anymore. And negative 2 times the square root of 5 is just that, negative 2 square root of 5. And that problem is now done. Now sometimes you don't even need to find the third side of that triangle. Sometimes you don't even need to find the third side of the triangle. For example, if you were asked to find the secant of the cosine inverse of 7 over 10, well, this is an angle, and you want to find the secant of the angle. And you know something about the angle. You have this statement. You know that the cosine of the angle is 7 over 10. And when it's a positive number, don't even worry about where cosine inverse is defined. All trig inverses are defined in quadrant 1. And everything's positive in quadrant 1. And in the other quadrant, they're all negative. Trig inverses are defined in 2 quadrants. For example, sine, it's in 1 and 4. Cosine, it's in 1 and 2. Tangent, it's in 1 and 4. Notice they're all defined in quadrant number 1. And everything's positive in quadrant 1. And for sine, cosine, and tangent, they're negative in the other quadrant. Sine is negative in 4, cosine is negative in quadrant 2, and tangent is negative in quadrant 4. So if you know that you have a trig inverse and it's a positive number, you are in quadrant 1. You don't have to worry about, oh my, what's that other quadrant it might be in. Okay, so we know the cosine of theta is 7 over 10, and we're in quadrant 1. Cosine is adjacent over hypotenuse. Now, here's the third side that we don't know, but we don't care what it is, because secant is, here's the angle, secant is hypotenuse over adjacent. It's just 10 over 7. And you want to find out what that is? Fine. 7 squared plus y squared is 10 squared. 49 plus some number, which I'm calling y squared, is 100. 49 plus 51 is 100. that is y squared, must be 51. So y is plus or minus the square root of 51. And since y is going up, it's positive. But we never need it. You can do this, make a mistake, you probably lose a point or two, but you never needed it. Okay. So now, what if the trig inverse is on the outside? That is, what is the sine inverse of the sine of 20 degrees? Now, sine inverse of something is equal to an angle. The sine of theta is equal to the sine of theta is equal to the sine of 20 degrees, and theta must be in between negative 90 degrees and 90 degrees. But that angle is in between negative 90 and 90. That is, if I let theta be 20 degrees, isn't sine of 20 degrees equal to the sine of 20 degrees? So theta is just 20 degrees. Done. Done. If you were asked to find the cosine inverse of the cosine of 74 degrees, well, cosine inverse of this is a number. When you take the cosine of 74 degrees, you get a number between negative 1 and 1. The cosine of that number is equal to an angle. This says the cosine of the angle is equal to the cosine of 74 degrees, and the angle must be between 0 and 180. But that angle is. That is, just let theta be 74 degrees. Now you may say, well, what if the angle is not between 0 and 180, or between negative 90 and 90? And now remember, you need to be able to do these same problems involving radians. Just convert the radians to degrees and do what I'm doing, and then in the end, maybe you have to convert them back. What if you were asked to find the sine inverse of the sine of 210 degrees? Well, this is equal to an angle. You take sine inverse of numbers and you get angles. This here is a number. I mean, take a calculator and calculate the sine of 210 degrees. You'll get a number. Well, this top statement, it means the sine of theta is equal to the sine of 210 degrees, and theta is in between negative 90 and positive 90 degrees. The problem is you can't say, oh, I'm done, theta is 210. No, because 210 is not between negative 90 and 90. So let us look at things. 210, it's 180 and then 30 more. That is, the reference angle is 30. And sine in this quadrant is the opposite, which is negative, over hypotenuse, which is positive. The sine is negative. Well, what other quadrant is the sine negative? And the answer is quadrant 4. And you have the same reference angle. The answer will be is theta is negative 30 degrees. If you take the sine of 210 degrees or the sine of negative 30 degrees, you get the same answer. Because 30 degrees. 1, 2, sine of 210 degrees is opposite over hypotenuse, negative 1 over 2. But the sine of negative 30 degrees, that is go back 30 degrees, is opposite over hypotenuse. Same answers. Same answers. Whether you take the sine of 210 to the sine of negative 30, you get the same answer. But we want to take the sine of negative 30, because that's an angle in between negative 90 and 90. So when I say theta is negative 130, remember, I called this theta. It says so. Call this theta. That is, if you didn't even write theta, the answer is negative 30 degrees. Sine inverse of sine of 210 is negative 30 degrees. Okay, let's do a couple more. What if you had the cosine inverse of the cosine of 420 degrees? Okay, you may just say, oh, the answer is 420 degrees. But that's not necessarily correct. This is equal to an angle. And we know something. We know that the cosine of the angle is equal to the cosine of 420 degrees, and the angle is between 0, and we call an angle theta, we take cosine of angles, is in between 0 and 180. Because that's what the range is for cosine inverses. And of course, 420 is not in there. So let's be clear where 420 is. Well, it's 360 and a little bit more, 60 more. 420 minus 360 is 60 degrees. That is, this angle right here, 60 degrees. But you know what? 60 is between 0 and 180. So we're done. Theta is 60 degrees. What if you were told that the tan inverse, to calculate the tan inverse of the tangent of 212 degrees? Well, we know that this is equal to an angle. The tangent of that angle is equal to the tangent of 212. The tangent of theta is equal to tangent of 212 degrees. And theta is in between negative 90 degrees and positive 90 degrees. Of course, just looking at this here, of course, theta can be 212. The tangent of 212 is equal to the tangent of 212. But the problem is that 212 is not in between negative 90 and 90. So we need to get it in between there. You have 180 and a little bit more. 180 and 32 is 212. This angle, 32 degrees. Okay, the reference angle is 32 degrees. This angle, 212. Now, tan inverse is not defined in quadrant 3. Now, in quadrant 3, is tangent positive and negative? Because I know tangent is defined in 1 or 4. Well, let's decide. Get our hands dirty. Opposite is negative. Adjacent is negative. Negative over negative is positive. Tangent is positive in that quadrant. Well, where is it positive between quadrant 1 and 4? The answer is quadrant 1. So you put the same reference angle, 32 degrees. So, 32 degrees. Theta can be 32 degrees. And you can check this out on a calculator. You can take the tangent of 212 degrees, see what you get, calculate the tangent of 32 degrees, see what you get, and say, wonderful, those answers are the same. And my answer, my angle, is in between negative 90 and 90. All right, now let's get some others. Okay, let's consider this problem. Suppose you were asked to calculate the cosine inverse of 2 times the cosine of 30 degrees. Well, let's calculate the cosine of 30 degrees. 30 degrees, 1, 2, square root of 3. Cosine, adjacent over hypotenuse. Now this is cosine inverse of 2 times cosine of 30 degrees, which is square root of 3 over 2. Coincidentally, the 2's cancel, so we're left with the cosine inverse of the square root of 3, which is square root of 3 over 1. Is the square root of 3 over 1. Now, this is equal to some angle. You take cosine inverse of a number. This is a number, and you get back angles. So we know that the cosine of our angle is square root of 3 over 1, and the angle is in between 0 degrees and 180 degrees. You have to know your definition. Now, since the cosine of the angle is positive, we're in quadrant 1. In fact, you don't even have to know that if the angle, if the cosine of the angle is positive. Now you may be saying, well, why do I bother to say I'm dividing by 1? Because when I draw my triangle in quadrant 1, I need to know 2 sides. Adjacent over hypotenuse. Okay, so what you can say at this point, and I'm sorry I didn't realize it earlier, this number is bigger than 1. There's no solution. The cosine of no angle is ever bigger than 1. Okay, the cosine of no angle is ever bigger than 1. Okay, so let's do a very, very similar problem. Let's do a very similar problem. What if on the top, instead of saying 2 cosine of 30, it says 2 cosine of 60? I'm just going to change the 3 to a 6. Okay, so this is cosine inverse of 2 times whatever cosine of 60 is. Well, cosine of 60, if I'm not mistaken, is a half. Opposite 30 is 1, 2, opposite 60 square root of 3. The cosine, or 60 degrees, is adjacent over hypotenuse, which is a half. And 2 times a half is 1. So we want the cosine inverse of 1. The cosine of which angle gives us 1? The angle can be between 0 and 180. Now, when it comes to 1s and 0s and negative 1s, I go to the doctor cosine graph. This is call this theta. This is asking the cosine of which angle is 1. And the angle can only be between 0 and 180. That is, we're not going to say 360. Cosine of 360 is 1. But our angle can only be between 0 and 180. And there's our answer. There's 1. That is, the angle is 0. This is 0. 0 degrees. cosine inverse of 2 times the cosine of 60 degrees is equal to 0 degrees. That is, the cosine of 0 degrees, which is 1, is equal to 2 times the cosine of 60. Remember, cosine of 60 is a half. 2 times a half is 1. That is, what's in these brackets is really 1. Cosine of 0 degrees gives us 1. So the answer is 0 degrees. It didn't even make sense. Okay. Let's go on and try another type of problem. This problem will be using those sums and difference rules. If you were asked to find the sine of, well, maybe you won't, we'll see. The sine of the sine inverse of a half plus the cosine inverse of a half. Now, I guess you could use the rule for sine of x plus y, but let's not. Let's call this theta 1, because there's 2 angles. Call the first one theta 1, and call this theta 2. Let's find out theta 1 and theta 2. Well, we know that the sine inverse of a half is theta 1. That means the sine of theta 1 is equal to a half. But we know angles, when we take sines of them, that give us a half. And since it's a positive number, we know we're in quadrant 1. Here is theta 1. That's the opposite. That's the hypotenuse. Oh, that's good old 30 degrees. Okay, so theta 1, this is really just 30 degrees. Now let's find out what theta 2 is. We know that the cosine inverse of a half is theta 2. That is, the cosine of theta 2 is a half. Well, since it's positive, a half is positive, we know we're in quadrant 1. Here is theta 2, adjacent over hypotenuse, 1 over 2. Ah, that is 60 degrees. Okay, so theta 2 is 60 degrees. So what we're really being asked to find is the sine of 30 degrees plus 60 degrees, better known as the sine of 90 degrees. But we can find the sine of any multiple of 90, not using a triangle, but using the graph. The sine of 90 degrees. Well, here's 180, here's 0, in the middle is 90. It's the high point. It's 1. The sine of 90 degrees is 1. Okay, that is, this mess is 1. That's 1. Okay, let's try another one like this. What if you were asked to find the cosine of the sine inverse of 2/5, sine inverse of 2/5, plus the cosine inverse of 3/5. Suppose you were asked to find this. Now, the thing is, when it comes to the sine inverse of 2/5 and even the cosine inverse of 3/5, we don't know that answer. We do not know that answer. Okay, but let's see if we can be clever. Let's just draw this. Let's call this theta 1. Actually, these should both be 3/5. That would make more sense. Theta 1 number 2. Let's see if we know something about this. Well, let's see. So, we know that the sine of theta 1 is 3/5. That means we're in quadrant 1. And we know that the cosine of theta 2 is 3/5. And 3/5 is positive, so we're in quadrant 1. Well, if this is theta 1, the sine of theta 1 is 3/5. 3 over 5. But you know what? The cosine of this, now this states that the cosine of theta 2 is 3/5. But you know what? The cosine of this angle is adjacent over hypotenuse. With respect to this angle, this is adjacent. After all, that would be the opposite. So this is theta 2. And then you should say, aha, theta 1 plus theta 2 is 90. Because if this is 90, the other two angles have to add up to the other 90. So this is nothing more than the cosine of 90 degrees. And if the sine of 90 is 1 or negative 1, this is going to be 0. But let's look at that statement more closely. I don't think we've done that yet. Okay, when this is sine and this is cosine. When sine is 0, cosine is 1. When sine is 1, cosine is 0. When cosine is negative 1, the sine is 0. When sine is negative 1, cosine is 0. When sine is 0, cosine is negative 1. When you have zeros, the other trig function will be either 1 or negative 1. When cosine is 0, the sine will be 1 or negative 1. Okay, so if you know the sine of 90 is 1 or negative 1, and we just said it was 1, then the cosine of 90 is 0. You hate that technique? Not a problem. Here is your cosine graph, and right here is 90 degrees. The cosine of 90 is 0. Okay. So you had to be clever to realize that theta 2 was just the other angle. So, and those two angles added up to 90 degrees, so we wanted the cosine of 90 degrees. Okay, let's move on to the next type of problem. Suppose you were asked to write this in terms of x. The sine of the tan inverse of x. Write this with no trigonometry, no sines or cosines or tangents. We know that this here is an angle, and we want to take the sine of that angle. We want to take the sine of theta. We know that the tan inverse of x is equal to theta. That is, the tangent of theta is equal to x. That is also known as x over 1. Now, theta for tan inverse can be either in quadrant 1 or 4. So, I guess we should do it for both of those quadrants, 1 and 4. Okay, so we know that the tangent of theta is opposite over adjacent. Opposite over adjacent. So the hypotenuse must be x squared plus 1 square root. Because when you square this, you'll get x squared plus 1, which is square root of x squared plus 1. Now, if you go into quadrant 4, the tangent of theta is told to be x over 1. Well, the hypotenuse will still be the square root of x squared plus 1. It will be the square root of this squared plus that squared. Okay, and the sine of this angle is opposite over hypotenuse. The same answer. So we wrote this in terms of x. That is, there are no trig functions there. And that's what we want to do. We want to write this as an algebraic expression in x. That is, no trig functions. No sines, no cosines. And that sines and cosines all over the place, but the last statement you said, or say, should only have x. You have the tangent of sine inverse of x. Well, call this theta, and basically we want to find the tangent of theta. And we know one thing about theta. Sine inverse of x is equal to theta, which means the sine of theta is x. That is x over 1. So I draw a triangle. Doesn't matter what quadrant you're in. Draw a triangle with angle theta, and the sine is x over 1. X over 1. Okay. The hypotenuse gets squared here, minus this gets squared here. After all, if you square that, you get 1 minus x squared. And then when you add on x squared, this cancels out, and you get 1, which is exactly where 1 squared is. Let's go over that again. And this is A, and then this is B. The hypotenuse, under the radical, the hypotenuse gets squared, minus the other leg gets squared. And it wouldn't matter if you had the A here and the B here. Under the square root, for the third side, the hypotenuse gets squared, minus the other leg gets squared. Okay, or, if you insist, you use the Pythagorean theorem, and you'll find out that the bottom leg is the square root of 1 minus x squared. Now, simple, we want the tangent of this angle. Tangent of theta is opposite over adjacent. It's x over the square root of 1 minus x squared. That problem is now done. That problem is now done. Okay, let us consider this problem. Let us consider the problem the cosine of the cosine inverse of x plus the sine inverse of x. We want to write this in terms of x. Well, if I call this theta 1 and I call that theta 2, well, the cosine inverse of x is equal to theta 1. That means the cosine of theta 1 is x, or x over 1. And the second statement, the sine inverse of x is equal to theta sub 2, that means the sine of theta sub 2, the sine of theta 2 is x. Now, if you take the cosine of an angle and the sine of an angle, you get the same answer. Those angles add up to 90 degrees. For example, if this is theta 1, the cosine is adjacent over hypotenuse. But you know what? If this is theta 2, the sine is x over 1, which jives exactly. Okay? That is theta sub 1 plus theta sub 2 is 90 degrees. This here is the cosine of 90 degrees. And the cosine of 90 degrees, 90 degrees is right there, right here. The cosine of that is 0. And 0 is in terms of x. It's a constant. I mean, sometimes you have f of x and it equals a constant, like 7. It's still in terms of x. Function of x means in terms of x. Now, I just want to show you another way you can do this problem. You really don't want to do it this way, but you can. And we'll see if we get caught up doing it this way. Remember, the cosine of theta 1 plus theta 2, using this addition rule, is the cosine of theta 1 times the cosine of theta 2 minus the sine of theta 1 times the sine of theta 2. Okay? Well, what is the cosine of theta 1? Well, what is the cosine of theta 1? Well, all we know about theta 1 is that the cosine inverse of x is theta 1. So, the cosine of theta 1 is x. Okay, this is x. What's the cosine of theta 2? Well, okay, let's find the cosine of theta 2. Well, let's see what the second one tells us. The sine inverse of x is theta 2. That means the sine of theta 2 is x. Oh, okay, the sine of theta 2 is x. Well, we need to find out are the two middle ones. What's cosine of theta 2 and what's sine of theta 1? Okay, so we know something about theta 1. The cosine of theta 1 is x over 1. X over 1. This piece must be 1 minus x squared. So, the sine of theta 1 is opposite over hypotenuse. You don't have to divide by the 1. It doesn't do anything. Sine of theta 1 is the square root of 1 minus x squared. Okay, minus the square root of 1 minus x squared times x. Now, what's the cosine of theta 2? Well, we know something about theta 2, the angle. We know that the sine of theta 2 is x over 1. So this left side must be the square root of 1 minus x squared. And you won't believe it, but the cosine of that angle is the square root of 1 minus x squared over 1, which is the square root of 1 minus x squared. Even if you have no idea what this is, when you take away the same thing, you get 0. Okay, so either way, you get 0. And please, the cosine over sum is not the cosine of the first angle plus the cosine of the second angle. That was not the rule. This here has always been the rule for the cosine of a sum.